All right, in assignment number 6, we're going to be talking about trigonometry. And so this is assignment number 1, or unit number 6. And assignment number 1, we're just going to be talking about the basics of trigonometry, what the some common ratios are, common trig ratios, and how we can use those trig ratios to find both side lengths and angle measures of different triangles. So let's go ahead and get started with some triangles that you should know about, special triangles, the 30, 60, 90 triangle. Here we have a 60-degree angle and a 30-degree angle, and this is the right angle. And if that's the case, we could finish this triangle, make it an equilateral triangle where all the sides would be 60 degrees. And if it's an equilateral triangle, all the sides would be the same, which means, let's say this side is 2, this side would be 2, and this side would be 2. But if it's just a 30, 60, 90 triangle, then this side is half of the 2, or 1. So we have the hypotenuse is 2, we have the short leg is 1, and then I could find the long leg using Pythagorean theorem. We know that if I call this x for the time being, I know that x squared plus 1 squared equals 2 squared. And then would have x squared plus 1 equals 4. If I subtract 1 from both sides, x squared is 3, which means x equals the square root of 3, which means this side is radical 3. So that means the sides of a 30, 60, 90 triangle will always be 1 for the short leg, 2 for the hypotenuse, and the square root of 3 for the long leg. So let's take a look and see what the legs would be for a 45-45 triangle. In a 45-45 triangle, we have a 45-degree angle and a 45-degree angle, and then a 90-degree angle. So that means these two sides are equal to each other. So let's say this side is 1, and then this side would also be 1. And then to find out what the hypotenuse would be, let's say we call that x. We would have that 1 squared plus 1 squared equals x squared. Well, 1 squared plus 1 squared is 2, so 2 is equal to x squared, which means x is the square root of 2. So that means this side here is the square root of 2. So that means that the lengths of the sides of a 45, 45, 90 triangle are 1, 1, and the square root of 2. Those are things that you're going to want to remember as we go throughout this unit. Let's talk about some special trigonometric ratios. We have sine, cosine, and tangent. Abbreviated like this, sine, cosine, and tangent. That's the way you see them on your calculator. And if we have a right angle here, the opposite side, no, that's the right angle. The opposite, let's say we have an angle here. The opposite side is here, because it's opposite the angle that we're talking about. The adjacent side would be the side next to that angle, and then this side over here is called the hypotenuse. And so it would be different if I was talking about maybe this angle. But if I'm referring to this angle right here, then I'm always talking about the side opposite that angle, adjacent to that angle, and the hypotenuse. And so the sine ratio is always the opposite over the hypotenuse. The cosine would always be the adjacent over the hypotenuse, and the tangent is always the opposite over the adjacent. One way that you might want to remember that a lot of teachers use to help their kids remember that is that it's so, ka, that's the H, and then toa. And that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. So let's use these signs, these trig ratios, to find some exact distances. Let's start with this one, the sine of 60 degrees. So we might have to go back and draw what a 30, 60, 90 triangle looks like. This is 30 degrees right here. We have a 60-degree angle here. So the sine of 60 degrees, we're talking about this angle, and we know that the sine is always the opposite over the hypotenuse. And so we know that this is 1, this is 2, this is the square root of 3. And so we're going to have the opposite, which is the square root of 3, over the hypotenuse, which is 2. And so the sine of 60 degrees, the exact value is the square root of 3 over 2. Now you could do the sine of 60 on your calculator and get a decimal, but it's going to be an approximation. It's not going to be the exact value because we really don't know what the square root of 3 is. Let's take a look at another one. Suppose we want to find the cosine of 45 degrees. Well, in order to do that, we're going to have to remember what a 45, 45, 90 triangle looks like. Let's suppose this is our 45 degree angle that we're interested in. We have the cosine, which is the adjacent. I'll put it over here. It's the adjacent side over the hypotenuse. And so the adjacent side here would be, this is 1, 1, and the square root of 2. So it's going to be the adjacent side is 1 over the hypotenuse, which is the square root of 2. And that's a correct answer, but it's not in very good form because we don't want to leave a radical in the denominator. So what we would have to do is we would take 1 over the square root of 2, and we would multiply the top and the bottom by the square root of 2. And that's going to give us radical 2 over the square root of 2 times the square root of 2 is the square root of 4, which is just 2. So we would write this in good form as the square root of 2 over 2. Let's take a look at one more. The tangent of 30 degrees. So I'm going to go back to this triangle here. Here's my 30 degree angle. The tangent is the adjacent, is the opposite over the adjacent. The opposite over the adjacent. So the opposite side here is 1. So that's going to be 1 over the adjacent side is the square root of 3. And so we could leave it like that, but that's not the best form. What we want to do is take 1 over the square root of 3 and multiply the top and the bottom by the square root of 3. And that's going to give us square root of 3 on top over the common denominator, which is 3. So it's the radical 3 over 3. Those are some exact values of trig ratios. Let's move on and talk about how we can find other lengths of other sides. So here we want to find the distance from point A to point B. We're going to assume that this is a right triangle here. We have 100 feet here, but we want to know what is this distance. Maybe we can't measure it because it goes across a lake or something like a pond or something like that, and we just can't stretch a tape measure across it. We can still find that exact distance or really close to that distance by using some trig ratios. So we know here we have an angle that's 65 degrees. We want to know what the hypotenuse of that angle is, and we know the adjacent side. So we know that the adjacent over the hypotenuse is the cosine. So we're going to take the cosine of 65 degrees, and that's going to equal the adjacent side, which is 100, over the hypotenuse, which we don't know, which we're going to let be h. And so we can then find the cosine of 65 degrees on our calculator, which is 0.4226, and that equals 100 over h. And so I can actually multiply both sides by h, divide by 0.4226. So the height is going to be 100 divided by 0.4226. And that gives me a value that is really close to 236 feet. So the distance from A to B would be 236 feet, and I wouldn't have to get out a tape measure to measure that. Let's take a look at another example. Suppose we want to find the height of a tree. It's going to be very hard to climb up to the top to see how tall the tree actually is. But if we get some measurements, suppose we go 30 feet away from the base of the tree, we get a measurement that this is a 57 degree angle. That's really all that we need to do to figure out what the height of that tree is. So the height of the tree is the opposite side of our angle, and we know the adjacent side to our angle. And so the opposite over the adjacent is tangent. So we would take the tangent of 57 degrees is equal to the opposite side, which we don't know. I'm going to call that x, over the adjacent side, which is 30. So I would just take the tangent of 57 degrees times 30, and x ends up being 46.2 feet high. All right. So those were two examples of how we could use trig ratios to find lengths of certain sides of triangles. Now we want to find the measure of angles within a triangle. And so suppose we have a ladder that's 2.5 feet away from the wall. The ladder is a 5-foot ladder. We want to know what is this angle X up at the top of the triangle, which would be this angle here in the actual picture here. So I want to find the measure of angle X. Well, I know that the opposite side is 2.5 and the hypotenuse is 5. So the opposite over the hypotenuse is the sine. So the sine of whatever X is equal to 2.5 over 5. Well, that's the same thing if I reduce that. The sine of X is equal to a half. And so what is the angle measure that gives us a sine of a half? Well, you might be able to remember the special right triangles that we talked about, how the short leg is half of the hypotenuse. And that's what's going on here. The short leg is half of the hypotenuse, which means this angle X has to be 30 degrees. But there's another way that you can find that X is 30 degrees. And that would be to take the inverse sine. So if you do the inverse sine of X degrees, so on your calculator it would be, you're pressed like the second, and then it would look like this, the sine of -1 of a half. And that goes the other direction. If you know that the ratio is a half, but you want to know the angle measure, then you would go the inverse sine of 1/2, and that would give you 30 degrees. And that's how we could figure out that the angle here has to be a 30-degree angle. Let's take a look at one more situation here. Suppose you see a plane. The plane is 300 feet up in the air, and it's 400 feet away from where you're standing, and you want to figure out what this angle is. Well, based on what we have here, we know that the opposite side is 300, the adjacent side is 400. That's the tangent ratio. So it's the tangent of X is equal to 300 over 400, which is the same thing as 3/4. So we would just simply go the inverse tangent of 0.75 or 3/4, and that's 36.86, let's go 36.87 degrees. And so this angle would be about almost 37 degrees. And so on our homework assignment for tonight, we're going to be finding exact values of trig ratios, 30, 60, and 45. And then we're going to be finding various types of angle distances or angle measures and distances of the sides of the triangle. That's what our homework is about today. We'll work on that and come back tomorrow and go over questions that you have.